Welcome back to Foundations Tutoring. Today we're going to be answering the question, what is the integral of x to the power of 5 multiplied by e to the power of x cubed? We're going to be using two different methods. Integration by parts, which is the one that I'm pointing to, and the second one is also integration by parts. That this is something that we'll usually see with definite integrals. And so what makes this definite is the a and b values, right? So it's going to be something along the lines of this, right? You're going to see a and b values, which in real life would mean actual values, so 0 and pi or 0 and 1, for instance. So let's get started. One of the first things that we need to note is the fact that we see x to the power of 5 here, but then we see x cubed over there. And so whenever we want to solve an integral, especially when we see something that we can be able to break down, then let's go for it, break it down. And so it would be x cubed times x squared times e to the power of x cubed. This is particularly important because we don't just want to remain with x to the power of 5. If we can be able to break it down, and when we go more into this lesson, it's going to be more revealing as to why x to the power of 5 would be way easier to use when it's broken down. So let's make notes of that. Let's just rewrite x to the power of 5 times e cubed is just going to be equal to the integral of x cubed times x squared times e x cubed. All right, and so now the second part of finding this integral is to now choose our variables. So I'm going to say let the derivative of g of x using the second method, I'm going to choose the derivative of g of x to be x squared times e to the power of x cubed. And the reason why I'm doing that is because whenever you want to use the derivative of g, try to find something that would be the most simplest. And so it does look like x cubed would be more simpler, but let's just go with this way and I'll show you why. And so now we're going to get the derivative. Well, now we're going to get the integral because we're differentiating and now going back to integrating. So we're going to have to find the integral of this. So let's just make note of that. The integral of this would give us x squared e x cubed. To integrate that, I'm like, this looks very familiar. We can use u substitution. So I'm going to say let u equal x cubed, so that du could be equal to 3x squared dx. And then I'm going to say dx is equal to du divided by 3x squared. So what I'm doing here is I'm just changing the subject of the formula, right? So it was first du, but now I'm changing it to dx because whenever we do this integral, we basically want to substitute whatever dx value we have here for this to be able to cancel out x squared with the x squared there. So let's do that. We're going to rewrite the equation as x squared e to the power of x cubed times du over 3x squared, right? We're substituting the dx over here. But also, since we've said u is going to be x cubed and du is equal to 3x squared, we can be able to cancel the x squares. So we'll be able to just have the integral of 1 over 3 times e of x cubed du. And let's not forget to change the subject of the formula, right? So if we're saying eu du, right? Because we changed the variable of x cubed, we said u is going to be x cubed. So now as we're substituting dx to here, we also just need to change the x cubed for u. Wow, this looks like a simple integral. This would be 1 over 3 times the integral of eu du. And we know that that would always give us 1 over 3 eu. But now, since we've chosen our u to be x cubed, let's substitute that back in. So we'll say that's going to be equal to 1 over 3 e to the power of x cubed. Cool. So now we've found g of x, which is 1 over 3 times e to the power of x cubed. So let's find out f of x. Since we've chosen g of x to be x squared, the only one remaining would be x cubed. So that would be our f of x. And now we're going to go back from f of x to the derivative of f of x to the derivative of f of x. So from here, we're going to differentiate d over dx of x cubed. This is going to give us 3x squared. 3x squared. Let me write this properly, just so that you can be able to see. Amazing. We're halfway through. Let's recall this method that f of x times the derivative of g of x is going to be equal to f of x times g of x minus the integral of the derivative of f of x times g of x. And so since we've gotten all of our variables, we can now proceed to do the formula. So I'm just going to copy and paste. So now that we've gotten our variables, and now that we've rewritten everything, let's just substitute this back into the original question. But let's just write that down. It's going to be equal to x cubed times 1 over 3 e to the power of x cubed minus the integral of 3x squared times g of x, which is 1 over 3 e to the power of x cubed. It's going to give us 1 over 3 x cubed e to the power of x cubed. Now we notice something here. What does this have in common? Well, we see 3's. These are going to cancel each other out. And so what's going to be remaining is x squared times e to the power of x cubed. Wow, this looks quite familiar. This is exactly what we just integrated, which gave us the answer of 1 over 3 e to the power of x cubed. So let's write that down. It's going to give us 1 over 3 x cubed e to the power of x cubed minus what we just found, which was 1 over 3 e to the power of x cubed. And most important, never forget your c. And that's the final answer. Thanks for watching.